Hey everyone, this is David, and I thought I'd do this little video of a school hack that I did back in my high school years when I did chemistry. This is for a friend in school mostly, but if you guys want to check it out, then you can go ahead. Like, comment, and subscribe to the video. Doesn't really matter too much to me. I just wanted to show this little cute little hack here for my friend Victoria. By the way, hi Victoria. All right, so it involves the little diagrams like these. If you don't remember these in chemistry, it was like one of the first things that you would do in chemistry, where you show an element and the number of valence electrons, then you show an element and the number of valence electrons, like so. You can look these up on the periodic table, just Google it. And basically what you have to do is show the bond between them. So in this case, it's something like this. This is a great example, hydrogen, hydrochloric acid, HCl. And apparently this is difficult for some people, so I thought I'd show a little hack at how you can picture this in your head very, very easily. So just to give you an example here, I'm going to say that this is Mr. Hydrogen. Say hi, Mr. Hydrogen. Hi. And here is Mr. Chlorine. I'm going to give Mr. Chlorine a little top hat. Like so. Looks more like a sailor's hat, but whatever. Okay, Mr. Hydrogen has one outer atom, and I'm going to say that he has one of something. So I'm going to say it's money. So I'm going to go with $1. All right, so Mr. Hydrogen has $1. Also, Mr. Chlorine has $7 because he has 7 outer electrons. 1, 2, 3, 4, 5, 6, 7. And here's 1. So the object of this game is that I want to make it so that everybody has either $8 or none at all. There's one exception to this rule, but let's just leave it at that right now. So what's the best way to do this? Well, I'm going to take the $1 from hydrogen and transfer it to chlorine. Why $8? Because in most of your periodic table, everything from neon, argon, krypton, and so on have 8 valence electrons, and they are known as the inert gases. So basically, it's 8. There's one exception. You probably noticed that I stopped at neon and I didn't go up one because that one is helium. And helium is an inert gas with only 2 outer electrons. Why is this so important? Well, the rule of 8 or nothing does not apply to anything in the helium family. Well, the helium column, I should say. And there's only one other element in that column, and that's hydrogen. Now, why is this so important? Well, I just showed you one method of how to get the bonding perfectly and accordingly. And I usually call this the Ionic Method because it's the transfer of electrons, because there's so much attraction that it transfers one. But this is not an ionic bond. Now, if you replace hydrogen with, say, sodium, then yes, you do have an ionic bond right there. There you go. However, I'm going to show you a method also known as covalent bonding. I'm going to take, well, this is the covalent method that I use. And with this one, what you do is, it's not just transferring, but to show you an example here, here's an oxygen. Here's an oxygen. I was about to write down nitrogen there for a second. Mr. Oxygen has $6, and Mr. Oxygen also has $6. So with covalent bonding, they share electrons because they don't have enough of an attraction to transfer electrons with each other. Well, in this case, you try to make 8 or nothing out of this, you can't. You pretty much just share $2 from each side so that each one has $8. Basically, they share a $4 pot and then they keep 4 of their own. So the diagram example would be, here's O, 1, 2, 3, 4, 1, 2, 3, 4. There you go. And it is a covalent double bond. Now, I'm going to go back to the hydrogen and chlorine problem here. And while you could do it by transferring one electron to the other, actually that's not how it works with hydrogen chlorine. What actually is happening here is a covalent bond. So you have Mr. Hydrogen who has $1, and then you have Mr. Chlorine who has $7. And the object is to make either 8 or nothing, except I mentioned that because helium only has 2 electrons in its outer shell, hydrogen only needs $2 to be fulfilled, or in other case, 2 or nothing. So yes, you could just transfer 1 like you do with sodium or lithium or any other alkali metal, but in hydrogen's case, that's not entirely true. What's actually happening is that hydrogen is sharing its $1 with chlorine, and chlorine is sharing its $1. So chlorine is $8 and hydrogen is $2. A proper block diagram for this would be as follows. Like that. So just to recap for you guys, the rules of the game that you should think in your head is this. Given an element, the number of dollars it has is the number of electrons it has in its outer shell. And you can just take a look at any periodic table to do that. You either transfer or share until every element has either $8, $0, or only if it's hydrogen, $2. All right, and if anyone wants to see more examples of it, I can show them in another video. This is it though for right now. I hope you enjoyed it. Please like, comment, and subscribe. I'm gonna do one more of these later today involving my favorite topic, computer engineering. Until then, see you guys next time. Bye.